have a blank sheet of paper, a blank sheet of line paper, and you also want to have your note sheet that looks like this, the energy and rate of reaction note sheet. So let's go ahead and get started. On your blank sheet of paper, you are going to copy these vocabulary words. So if you need to pause the video, do so. But title this page Energy and Rate of Reaction Vocabulary and copy all of the vocabulary words here along with the definitions. I'm going to continue with the lesson, but you need to pause this video so that you can copy the vocabulary. Okay, so within the lesson, we are going to be coming across this vocabulary. And on your note sheet, again, the one that looks like this, you are now about to fill in the blanks based on what you hear and see in this lesson. Pay attention to what it is that you are looking at so you know that when you are writing and that you're writing things in the right spot. If at any time you get lost or confused, then you need to rewind the video or pause the lesson so that you stay caught up. All right. Just let's take a moment and watch a short video about endothermic and exothermic reactions. If you've already seen this video, then you can rewind. I know one of the blocks did watch the video, but not everyone has saw it.
Chemical reactions involve energy being given off or being absorbed. While energy is neither created or destroyed, it does change form or position. An exothermic reaction releases energy. Heat is given off in an exothermic reaction, as in this burning piece of paper. The chemicals used to create explosions in this marble quarry also produce chemical reactions. In contrast to exothermic reactions are endothermic reactions. An endothermic reaction absorbs energy, which results in an overall lowering of temperature. This antacid, when dropped in water, creates an endothermic reaction and causes a lowering in temperature.
Okay, so that was just a bit of review about endothermic and exothermic reactions. We talked about that before. So on your paper, here's a basic review. For a chemical reaction to occur, we understand and realize that bonds must be broken and or formed. So for a chemical reaction, bonds must be both formed and or broken. That's review. We talked about that already. For instance, with hydrogen and oxygen, they form a bond creating water. And then through electrolysis, we can break that bond, creating hydrogen and oxygen separately. Example here would be iron and copper sulfate. Copper breaks away and iron bonds with the sulfate. So you then end up with copper and iron sulfate. All right, making and breaking bonds involves energy. Chemical reactions always involve energy change. Like the video told you, energy cannot be created. However, it can transform into other substances. Not transform meaning being made into other substances. It could enter into other substances. So here, chemical reactions always involve energy change. So it takes, let me go back to that for a moment. It takes a lot of energy to break or form these bonds. It can't be done without energy, just like you can't move about without energy. So just like the law of conservation of matter, there is a law of conservation of energy. The word conservation, conserve, means to save. So the law of conservation of energy states, energy cannot be created or destroyed. However, energy can change forms and be transferred from one object to another. So think about the wave. You create a wave and transform it to another person, or transfer it to another person. All right, this type of energy reaction takes in heat from the surroundings and causes temperature to fall. Notice it's being transferred from the surroundings, so it's taking it in, For instance, sodium chloride is going to take in energy, and that bond is now going to break and give you sodium and chlorine separate. So you have sodium chloride plus the energy and give you sodium and chlorine separately. Whenever it takes in energy, that's an endothermic reaction. Your example is down here. You should be basically writing anything that's in the orange, so pay attention to the things that are in the orange. So you have bullet point I, there's this endothermic reaction, take in heat or energy from the surroundings and cause temperature to fall. Your example is this equation here. Again, your example is this equation here. Breaking bonds require energy. It is a certain type of reaction. It is a certain, breaking bonds requires a certain type of action, meaning that it's going to require that energy to break these bonds. So this would be, again, an endothermic reaction. So whenever bonds are broken, it's endothermic. It requires that energy. Think about if you and your friends are friends. In order for that friendship to break, it's going to require some energy, or it's going to require some real heated tension or a heated argument in order for your bond to break. The type of reaction that's going to give off energy, again, you have sodium and chlorine. They're going to bond together, and they're also going to release some energy or some heat, because remember, heat is energy, and this is an exothermic. Remember, energy is being released. So whenever new bonds are being made, it's going to give off some energy. Think about how you feel when you and your friend, you make a new friend. You are now warm and cozy that you have a friend. You feel happy. You have that warm feeling. And again, this is exothermic reaction. And your example is down here. There are some types of energy that is released during an exothermic reaction. For example, with the glow sticks, this would be light energy. When you break that glow stick or you shake it up, then light is given off, exothermic. Your batteries in your cell phone would be electrical energy. Once you put the battery in the phone, it's going to give off electricity for you to be able to use it. Example like a campfire, this would be heat energy. Once you strike that match or add that fire to that wood, it's going to give off heat. All right, now we're going to talk about rates of reaction and what that has to do with energy. What does the rate of reaction mean? Well, it's the speed of a reaction. So your rate of reaction is the speed of the reaction. So how fast the reaction is going. This is your definition. The speed of different chemicals reaction varies hugely. Some reactions are very fast and others are very slow. So it all depends on the chemicals that are being combined. So what is the rate of these reactions? If you look at a rusty um, bicycle chain or a chain, that doesn't happen overnight. That doesn't even happen over a month. It takes a long time. So this is a slow rate of reaction. Baking cookies. It doesn't happen very quickly, but it does take a little bit of time, but not as fast as fireworks. So baking cookies would be a medium rate of reaction, and explosives would be a very fast rate of reaction. So notice uh, when we talk about reaction, we're talking about how the chemicals react together. When we're talking about rate, we're talking about how fast those chemicals react together. We haven't written anything yet. We're moving on now. Still not writing, just thinking about some things. Why are some reactions faster than others? This is what we're going to talk about. But think about bumping cars. If you ever rode in a bumping car, you don't react with someone until you actually hit them. So you have to collide with them in order to react. If you're driving around avoiding everyone, then you're not reacting. You're not bumping cars. You're just driving in the car. But once you start to bump the cars, then that's a reaction, and you're going to see those little sparks at the top fly where your little parts of your car have collided with each other as well. So reactions take place when particles collide with a certain amount of energy. This information is on your paper. In writing, the minimum amount of energy needed for particles to react is called activation energy. So your activation energy is the minimum amount of energy needed for particles to react. This is different for each reaction. Activation energy means the starting energy. To activate means to start. So when you strike a match, you're activating the reaction. You're starting it, and that's your activation energy. The rate of reaction is going to depend on two things. One, it's going to depend on the frequency of collisions between particles. This means how often do the particles collide or bump into one another, and the energy with which particles collide. How much force is needed for the particles that are colliding. If particles collide with less energy than activation energy, then it won't react. So if it's not enough to start it, then it's not going to react. The particles will just bounce off one another. If it is enough force or energy, which is equal to the activation energy, that will get the process going. Now you should be flipping your papers over, but I want you to pay attention to the video because the video is going to talk about the factors that affect the rate of reaction. While you're watching it, you're going to be filling out 1, 2, 3, 4, and 5. These are going to be the factors that affect the rate of reaction. So things that affect how fast or slow the reaction happens. Okay, I need to pull the video from another location. All right, here's the video.
Different chemical reactions have different reaction rates. The reaction rate is the speed with which reactants turn into products. Temperature is one factor that affects reaction rate. Generally speaking, an increase in temperature increases the reaction rate. Take, for example, these glow-in-the-dark sticks. The stick in the cold water does not glow as brightly as the one in the hot water, because the hot water accelerates the reaction rate between the substances inside. Surface area also affects the reaction rate. Surface area refers to the amount of the material that comes in contact with other reactants. For example, this piece of chalk has less surface area than the same amount of chalk powder. A piece of chalk with less surface area reacts at a slower rate than the chalk powder, which has a greater surface area. Concentration can also influence reaction rate. Concentration is the amount of a substance in a given unit of volume. By increasing the amount of reactants, the reaction rate tends to increase. For example, by adding more oxygen to this fire, the fire burns faster. Sometimes other chemicals called catalysts aid in accelerating reaction rates and are common in most living things. A catalyst is a substance that increases the reaction rate but is not changed by the reaction. Most animals contain catalysts called enzymes that accelerate important chemical reactions, such as in the digestion of food.
All right. Some of the 5 factors that you should have gotten from that video should have been temperature, concentration or pressure, concentration and pressure actually. Surface area, catalyst, and inhibitor. Reactions do not proceed at a steady rate. They're going to start off with a certain speed and then it's going to slow down until it stops. Now, what that means is your chemicals are going to react together and they're going to keep reacting. And they're going to keep reacting until there's no more reactants and now it's a full product. So, for instance, hydrogen and oxygen are going to react together until water is created. Once water is created, there's no more hydrogen and oxygen to react. So, the reactant amount decreases as the product amount increases, and the reaction rate also decreases. So, anything that increases the number of successful collisions between a reactant will speed up the reaction. So if you're trying to get these particles to bump into one another, like bumping cars, you're trying to get them to bump into one another to create a reaction so that you can have a final product. If you increase the amount of times they bump into one another, you increase the reaction, which then will produce the product. So what factors affect the rate of collision, the rate of reaction? Again, you have temperature. As the temperature rate increases, the rate of reaction will also increase. Concentration and pressure increases, the rate of reaction will increase. Surface area increases, the rate of reaction increases. Notice there is nothing in orange, so you shouldn't be writing yet. If you add a catalyst is something you add um, to the reaction so that you can increase the reaction, but you don't change what the substance is. So, for instance, when people make bread, they add yeast to speed up the bread making, but yeast doesn't change the fact that it will be bread. An inhibitor is something you add to reaction if it's going too fast and you need to slow it down or stop it, but again, it will not change it, like preservatives in your food. Those are added to your food so your food won't spoil. It's going to slow down or stop spoiling. All right, reactions do not proceed at a steady rate. They start off at a certain speed again, and then they slow and slow until they stop, because eventually you're going to have a product and no more reactants to react with one another. Now, as the reaction progresses, the concentration of the reactants are going to decrease, which means, again, as your substances are colliding with one another, you're no longer going to have reactants, you're going to have more product. This reduces the frequency of collisions between the particles, and so the reaction slows down. If you don't have anything to bump into each other, then it's going to stop the collision because you're having more of the product. So if we look at this picture here, the red and the blue are two different substances. The purple is the product. So you have the red and the blue as the reactants, the purple is the product. Notice you have product being formed and then more product being formed, less reactants, more product, less reactants. Eventually, you have all product, no reactants, so therefore there's no need for a reaction anymore. All right, still not um, writing. I'm sorry, you're still not writing on your notes. You are now going to take out another separate sheet of paper. And this is just a little video quiz. And you're going to title it Collision and Reaction Summary. And you're going to copy these questions and fill in the blank. I'm going to keep going. You need to rewind it if need so. Uh-oh. All right. Now let's talk about temperature and the collisions. How does the temperature affect the rate of particles in a collision? We're now looking at the temperature portion of your notes. Let's just take a look at these pictures first. If the room is freezing cold, then you're going to move as less as possible because things are starting to freeze and you don't want very much movement, like putting water in a freezer. Those particles are going to stop moving as much, and they're going to freeze and freeze, and there's going to be no movement. So when you're in your room and it's cold, or you're somewhere and it's cold, you want to bundle up and you just want to be in one spot. However, if the temperature is hot, you're kind of moving all around, things are moving, you're not trying to be bundled up in one spot, you're kind of going. So on your paper, the higher the temperature, the faster the rate of reaction. In many reactions, a rise in temperature of 10 degrees causes the rate of reaction to almost double. Think about the winter. You don't really want to go out much in the winter and do much, but in the summer, you want to be out and about moving. It's a higher temperature. So why does increased temperature increase the rate of reaction? Again, at your notes. At a higher temperature, particles have more energy. This means they move faster and they are more likely to collide with other particles. If you got up in the room and you started running around, chances are you will bump into a lot of people. If you just walked around slowly, you wouldn't bump into that many people. When the particles collide, they do so with more energy, and so the number of successful collisions increases. So chances that they will bump into each other will be more likely because they're moving around a lot more. Here is an example. Unfortunately, this example is not working, so I will just move on. So why are batteries more likely to run down more quickly in cold weather? Sometimes you see cars stall and not start up when the temperature is cold. The reason for that is at low temperatures, the reaction that generates the electric current proceeds more slowly than at higher temperatures. So when it's very cold outside, it slowed down the possibility of those particles colliding with one another, your reactants colliding with one another because the temperature is so low. So it decreases the frequency. Remember that word from the front. So the amount of times that your particles will collide, which means there's not enough activation energy, not enough energy to start the process to get it going. So sometimes people have to recrank their car and recrank it to kind of give it that activation energy, or give their car a jump start to give your car that activated energy so that you can give those particles enough energy to collide with one another so that the car starts. Yes, starting your car is a chemical reaction. All right, on your notes, concentration and pressure. Concentration means the amount. We don't mean how well you're focusing for this. It means the amount. The higher the concentration of a reactant, the faster the rate of reaction. So the more amount of stuff, of reactants that you have, the faster the reaction rate will be. So why does increased concentration increase the rate of reaction? So that means why does the amount of the reactants increase the rate of reaction? Well, the higher the concentration, there are more particles in the same amount of space. This means that the particles are more likely to collide, and therefore they are more likely to react. If I start closing, if we add more people into this room, then chances are more people are going to bump into one another because we're adding more, we're increasing the amount. So take a look at these pictures. The more stuff, the more they're going to bump into one another, which means there's going to be more of reaction. The effects of pressure on the rate of reaction. Well, pressure means the amount of space, how much room is available for these reactants to react. So the higher the pressure, the higher the rate of reaction, which means, again, if we close this room in and leave the same amount of people and we start closing in the walls, you are going to start bumping into one another and probably freaking out with the reaction because of the amount of space available. And that's the same thing with particles, reactants to create a product. So why does increasing the pressure increase the rate of reaction? Well, like I just said, as the pressure increases, the space in which the gas particles are more moving becomes smaller. All right, so the particles become closer together, increasing the frequency of collisions. This means that the particles are more likely to react. Surface area. Any reaction involving a solid can take place only at the surface of the solid. If we actually split it into several pieces, the surface area increases. What effects will this have on the rate of reaction? Well, let's take a look here. Notice this block only has one front, back, side, top, bottom. If we split it in half, we now have two fronts, two backs, two sides, four sides, two tops, and two bottoms. And when we split it in half even more, we have more surface area, so there's more space for the reactants to hit one another. So this means there is an increased area for reactants for particles to collide with. The smaller the pieces, the larger the surface area. This means more collisions and greater chance for the reaction. Now, catalysts just speed up the reaction. They do not add to the substance. Why is this important to you? Well, in your body, you have something called an enzyme. An enzyme helps to speed up your digestion of your food. Without that, you would be holding on to food for a long time. Many catalysts are also in transition metals. For example, nickel is a catalyst in a product for making margarine. Either one of these would be your examples. Iron, platinum in your catalytic converters for your car. More catalysts in the industry making and saving money. So things like your washing products. And then an inhibitor just slows down or stops a chemical reaction and it does not add to the substance. So example here would be things like preservatives that add to your food. That are added to your food to slow it down from rotting or molding. And this would conclude your lesson.